Anywho, the main strategy when we're verifying these trig identities is to write everything in terms of sine and cosine. Okay, so notice we have a cosecant here, we have a cosine and a cotangent that's multiplied together, and somehow through some math magic we're going to end up with that being the same thing as the sine. Okay, so if I took the cosecant of an angle and subtracted the product of these things of the angle, that's the same as taking the sine value at that angle. Who knew? But let's see if it's actually true. So, write everything in terms of sine and cosine. So the cosecant, hopefully you know, is 1 over the sine. That is its reciprocal. The sine is 1 over the cosecant, and the cosecant is 1 over the sine. Minus, well, cosine is fine, so let's just leave that one alone. But cotangent I can write as cosine divided by sine, because that is the cotangent's reciprocal identity. Okay, tangent is sine over cosine, cotangent is cosine over sine. So now I have some algebra to deal with. I have a number times a fraction. So I do top times top and bottom times bottom. So we can put cosine over 1 so that we can actually do the numerator's product and the denominator's product. Okay, so let's see. We have 1 over sine over here minus cosine times cosine is cosine squared, and 1 times sine is sine. Sure enough, there we go. So far, so good. So now I have a fraction minus a fraction. Okay, we learned how to do fractions way back in elementary school, and as long as the denominators are the same, I can actually subtract these. And of course, you only do subtraction in the numerator. And since there are no like terms, we simply write them down next to each other, 1 minus cosine squared, and I'm still dividing all of that by the sine, the single denominator. Okay, so now we have to do some substitution. So there is a Pythagorean identity, that's not what I want, there we go, that says the cosine squared plus the sine squared equals 1. Okay, so if I bring the cosine over here, I get to know this little manipulation, that 1 minus the cosine squared is also the same as just the sine squared. So right here, instead of 1 minus cosine squared, I'm going to write sine squared. That is a trigonometric substitution. Okay, I'm replacing 1 minus cosine squared with its trig equal. Okay, which is very handy because now it looks like I can actually get sine out of this, because sine squared is, of course, anything multiplied by itself, so sine times sine. And one of these divides, and I am just left with sine, which is exactly what I should have. Okay, so through some algebra and a little bit of trig substitution, we're able to verify that all this stuff on the left actually does equal the same thing as taking the sine of that angle. Okay, so let's come over here to number 8 and see if we can do something similar. Now remember, in these trig problems, you're only allowed to work on this side. So we are not allowed to manipulate secant and cosecant. That is what we are trying to accomplish. That's our goal, is to have the left side look the same as the right side. Okay, so we don't do anything on the right side, we only manipulate the left. So let's get to manipulating. Once again, I'm going to replace tangent with its sine and cosine equivalent. So tangent is known as sine over cosine. And I'm going to replace cotangent with its sine and cosine equivalent, which is cosine over sine. Okay, now you say, how does that help us? That doesn't have secants or cosecants, but just wait. It will probably come through, because that's our number one strategy, is replacing with sine and cosine. Okay, so now I have, once again, a fraction plus a fraction, but now I don't have the same denominators. So we learned in junior high that if you want to have two fractions added together, they have to have the same denominator. So the least common denominator is what we need to get. So on the left side, I multiply by sine over sine. And on the right side, I multiply by cosine over cosine. Okay? I am multiplying these equations, both things, by 1. So mathematically speaking, I'm not actually changing anything. I'm just making it look different than it did a second ago. But the math says it's still the same. So now let's do this product. So sine times sine is sine squared over sine times the cosine. Plus cosine times cosine is cosine squared over sine times the cosine. Okay, so I've just done this product to numerators and I have my same denominator. Which is fantastic because now I can actually combine the tops. Here we go. So I can actually add these two things together. And since they're not like terms, I just write them down next to each other over the single denominator of sine times the cosine. Okay, now as we discovered over here a second ago, the cosine plus the sine squared, cosine squared plus sine squared, is equal to 1. So my Pythagorean replacements, instead of sine squared plus cosine squared in the numerator, I'm going to replace that with just the number 1. Okay, it's trigonometric equal. So I am substituting so that I have things that make it easier. Well, who knows? Okay, so now I have 1 over the sine times the cosine, which I can split into 1 over the sine times 1 over the cosine. Okay, that is perfectly mathematically okay to do that. Maybe you can't see that since it's on a dark background, so here you go, 1 over sine and cosine. This says sine and cosine here, by the way. So now I'm going to do one more trig substitution. 1 over the sine is also known as the cosecant. And 1 over the cosine is also known as the secant. And I believe that's how we wanted it up there. Is it? Secant, cosecant? Secant, cosecant, cosecant, secant, whatever. It's the same thing. Multiplication is commutative. Okay? So using a little bit of algebra and some trig substitution, we were able to verify that adding together these two trig things is the same as multiplying those two trig things.